We're recording. Yeah, and I guess I should go bloop. do my little sound effect after I got the record button hit. Okay. We're gonna do this thing because by popular request. So that looks fun. That looks fun. And so let's try to figure this thing out. We got a 4 and a 9. We got a y and a y to the fourth. Okay. Does it say to switch? Then just push forward. No, I'm just joking. Yeah, we could switch. What if we did this instead? Would this be a little better? You're you're what if I did oh, hold on. And you you already know what I'm gonna do. Man. That's the yeah. What about that? Is that even better? That's a whole lot better, isn't it? You could switch around your variables, but I think that doing it this way is immensely easier. Hi, I'm happy you're here. So doing it this way, we have to add 1 to the power, divide by the new power. So then leave this guy alone. Add 1 to the power, divide by the new power. From y to y to the fourth. See, switching the variables would take a lot of time because I'd have to draw the region and all that stuff. So if I just did it, the way they do it, mostly. So this is a 2 that comes out to the front. When I toss these guys in here, it's going to look nasty, but let's just kind of see what happens. So if I plug a 4 in there, 4 times a half is 2. But when I plug in this guy, well, he just becomes a 1/2. So did you see how I did the 4 and the 1/2 makes 2? Right. Powers of powers multiply. Yep. You got it. I'm going to distribute because polynomials. It's not polynomials anymore. What would you call this? What isn't that 5/2? But what do you? Oh, and 1 1. Look, and so when you're multiplying your bases, you what your powers? You add them. Look at that. What is it called whenever it's like all just? It's not polynomial, but it's numbers with powers. Number powers. Power numbers. P series. No. Don't go down that road again, Chad. Don't go down that road. Cal 2, no. So I add 1 to the power, divide by the new power. That would be, if I add 1, wouldn't that be a 7? So then 2 over 7, y to the 7/2. And then this is easy. From 4 to 9. The 2's combine there. And then the 2's cancel over here. Calculator, dun 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 dun, the calculator, bum 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 ba-dum. And I'm being super lazy. Now that we got Desmos in our lives, things are like so much easier. And you're like looking at that, nah, Chad, nah. Well, okay, here's the thing. We're getting like square root answers, right? But even when I plug in a 9 and a 4, it's still okay. Why is it okay to plug in a 9 and a 4? Why am I not getting square root or something stupid? Yeah, because these are perfect squares. So even with a square root in there, I know it's funky, but we are getting something. Oops. I would have had to, yeah, a little bit more manual, let's just say. Yeah, a little bit more manual. 80, oh man, 8181. I also want to like just tell you that it's dark over here in this corner because the lights are off and I can't see the keyboard. And you're like, yeah, Chad, okay. Excuses, excuses. Let's try that. Back to the homework. And I really feel like this is not going to work. But it did! Okay. Yeah, with the section 1 and section 2, you get a lot of numbers like that. Yeah. I have our Algebra 1314 OER class that uses my Open Math instead. This is the last semester we're doing that, but they get funky numbers often because it's like, I don't know. I don't know if they're expecting it at this point or not. It's kind of sad. 1314 algebra. Like, why do you do that to me? It's like My Math Lab, but free. No, I can't use that one anymore. That one only worked with Blackboard Original because now they have security updates that don't let me do the fun things I used to do. Yeah, I hacked the system. Yes, and then I put my code on GitHub for everyone to see. So take that, Blackboard. I think I just muted myself. Let me not mute myself. Hold on. Am I muted? Let me see. Hold on. I think okay, I'm not muted. You can still hear me. That's all that matters. Okay. So good. All right. So, any others? That was the only one I got. Okay. The website went down last night. Website got stuck. I know. I've heard that. I heard about that from others. Yeah. Yeah, I was fixing things. Good though. Good. Okay. Awesome. Then back to what we're doing. Funmath.com. Don't go there. So I wrote up all the formulas ahead of time for this next problem. We already know the X bar, Y bar stuff. And that's, I would say, easy compared to what we're going to be doing here in a minute. But notice that in the end, they just say, this is a formula, go and do it, right? So in the end, I'm really not too scared. I just need to be careful when I'm doing that. But before any of that, I have to say that all of these integration limits are all going to be the same. So we need to figure out what my region is going to be, and then I could just, pop it all in and get it done. So blah dy dx is what I'm guessing. Once I have this set up, pop, and we're done. Hopefully. So we have y equals x and y equals negative x. So I'm going to start graphing that, I guess. So y equals x, y equals negative x. It's like just two 45-degree lines. I did not draw 45 degrees, but it's okay. Y equals 2. And that was it? Oh, do you see it now? What's the region look like? It's a triangle. Yeah. So let me draw that better now that I kind of know what's going on. So 45 degrees, and then we have y equals 2. And we're wanting this zone in here. Where is it colliding right here? What's this point? Yeah, and over here? Perfect. And this guy? Thank you. Trivial solution. Oh, they're not in linear. So, anyways, do we do much with the trivial solution? Okay, cool. It's online, bro. It's just a hands-off deal. They come and say, hey, does this proof look good? I'm like, yeah. Oh, I shouldn't have recorded that. No. It's fine. I'm super proof intensive here, but I'm also very liberal in grading them because it's the first one they'll ever see. You've never seen proofs before this, so yeah, that's. Anyways, um, we need to find our limits for this. Then, did you want to do two different integrals? Top, bottom, top, bottom. Ew. Or even better, what if I were to do this? Go ahead. Hmm. Yes, for this and this, totally agree. But all the rest of them have a density in a way that a variable, right? Oh, and even this has a variable density just to begin with. So I guess we can't even do that for the area. Ooh, that's gross. But that's okay. So I would recommend doing this guy. Therefore, I probably am going to end up doing a dx dy. So we got top, we got bottom. So I'm going to do not y equals x, but x equals y and negative y. And then again, y should go from 0 all the way to 2. So that's my recommendation for everything that we're going to be doing here in a second. So the only thing that I forgot is that we actually have a density here. I'm going to need to tack this guy in alongside with whatever else I have to mush together, okay? So if it wasn't complicated enough with all these formulas, now I've added more to it. Do you understand how I don't want to say rotated. It's kind of like a flip. That I flipped my axes to make it easier. Yeah, go ahead. Yeah. Yes, because I'm looking at my this line and this line. So this bottom and is going negative. Isn't this like negative y and well, it's negative x, all that kind of stuff, right? So it's negative. So that's definitely on the bottom. Negatives are on the bottom, and then I got a positive up there. Cool. And notice that the one coming up is going to be a y. So whatever this is here, it needs. Ah, I need to do it better. Whatever this is here, it needs to accommodate for that variable. Therefore, I'm not putting x's, I'm putting y's. So far, so good. Then at the end, I'm wanting y values, and so this is a y equals. This is a y equals. And so on this axis here, or even over here, what's the lowest y value? And then it goes to 2. Yep. And so here I'm just doing horizontally. Very good. Very good. Good question. Okay, I'm gonna erase right here so I can get some more room, and I'll like redraw it just so I feel like I did something good today. Yay! Boop, boop, boop. Yay! This is a y. This is an x. Okay, so let's get to it. I'm gonna start with the basic integral. I'm just gonna do this one basically. So we got double integral of 6y plus 3 dx dy. In terms of x, nothing. So that's kind of nice. I'm then going to just say y plus y dy. Oh, hold on. It's not double anymore. I already took an integral. Why did I do y plus y? Mm-hmm. Yep. Y minus a negative y. Two negatives make a positive. I know that's a tiny bit of a shortcut. Because that's just 2y, I can actually distribute that pretty easily. So then I got 12y squared plus 6y. Dy. Integrating that, divide by 3, so we get a 4y cubed. Here, divide by the 2, we get a 3y squared from 0 to 2. The 0 obviously cancels. 8 times 4 is 32. 4 times 3 is 12. 44 is Not the answer. Not, but it's one of our 5 answers. Maybe 6. I don't know. It's quite a lot, actually. Got a long way to go. But 44, we got that much. You know, and let's just pause for a second. If you don't mind, can I cheat for a minute? Thanks. I didn't wait for a response. There. Let me go to Desmos graphing. Because this is homework. Not all of this is on the exam. Let's just verify that we got what we want, in a way. Dx, dy, okay. Now, I didn't really worry about that, but what I want to know is, all I'm going to do is, like, alter this a tiny bit, right? Like, I'm going to put an x times that amount. You know what I mean? I'm going to do a y times that amount. And then I'm going to do an x squared times that amount. And then I'm going to do a y squared times that amount. And like all of these 5 different things, I just kind of start mushing them together, right? Divide this by that, add this to that thing, and there's my answers. Once you have that form, it's pop, 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 done. I know you don't have that on your exam, but it's a give and take, you know what I mean? Like, notice 0. So, like, I just want to flash the answers right quick. We have a 0. So, like, we are in the right direction, for sure. Okay, so I think everything's going to be happy. Cool? Okay. So let's just keep doing it by hand, of course. There we go. All right. There's my little recommendation. So, double integral now of x times all this stuff. And I know that we just got 0, but I want to verify that manually. Dx, dy. When I integrate in terms of x, don't I get x squared over 2? Watch this funniness. 1/2 times, I'll do x squared just for right now, okay? Dy, because I need to plug in negative y and a positive y. So I got a y squared minus a y squared. Pause. Why did I have, the last time I had y plus y, right? 2 negatives make a positive. Why is that not happening this time? Why do I have a minus sign there instead of a plus? I didn't like the last sentence, but the first one was great. So, because the square would make it positive regardless. You're kind of like saying that's a negative y squared, and that's going to be positive, leaving this minus sign alone. It never really did 2 negatives make a positive. So in a way, it's like 0 right there. 0, done. We don't have to keep going. And yet again, that's another part of our answers that we'll use here soon. You do have a lot of room, right? You're writing tiny now. An interesting thing, back a month ago, let's say, even 2 months ago, this was a pretty easy class. I warned you, didn't I? That it would start to get a little bit more. You love this. Oh. This is a terrible exam question. Yeah, I know. I need to make the exams. So I have a y, but there's no x's still. Therefore, just like the other time, I'm going to end up having a 2y attached to it. Like, in a way, I already did the math that I did on the previous one, so I don't really need to keep doing that again, right? So that's 2y squared. So when I distribute, it's very similar to the other one, except that I have an additional y in there. See, it's like almost a duplicate of the first one. I just have an additional y in my powers, okay? Because I have an additional y in the front. Makes sense. So I'm going to go to the fourth power here. So divide by that, I get a 3. Here I'm going to go to the 3 power, so I'd have a 2 left over. 0 to 2. So 32 times 3 is like 96. And then here we have an 8 times 2 is 16. It's going to be like a 108, I think. 118. It's going to be 118. Yeah, 118. So already I can get my y bar, x bar. Obviously 0 divided by anything is 0, but 118 divided by 44, 16 over 11. Would they both cancel a 4 essentially? The 118 and the whatever. I mean, it looks like it. Happy days that I have all the cool formulas for the next ones, and they're perfectly in line for my next set of integrals. I don't have to move anything around. No arrows. As in, like, right here, I could just say equals. Yay! Anyways, so my initial integral is going to be a little bit more. Oh, you know what? Hold on. I'm a little bit nervous right now. Wait. I'm not nervous. I'm not nervous. I'm not nervous. My bad. Just similar to the other ones that we just had, right? I'm going to do a 2y and attach it there. And so it's going to be even similar to the last one, where it's going to be now 12y to the 4th plus 6y cubed. You can see the similarities, right? Maybe this is a good test question. Okay, I can't tell if you're being serious or not. Fifth power is not going to be happy anymore. So, and then 4 again would not be perfectly lined up from 0 to 2. Okay, yeah, I'm starting to like run out a little bit of room there. Can I do this in my brain? What do you think? Okay. So I got 32 times 12 divided by 5. I'll wait for you to do that one. Yeah. Right? 2, 4, 8, 16, 32. Wow, man, I thought you were good at this. I'm just playing. Yeah. Okay. Look at that wall of like math. I would say wall of text, but it's a wall of math. And that's so cool though. Y'all ever like go home and show everyone what you do? Like show off your cool workbook and really? Yeah. Yeah, exactly right. Again, I don't need a 0 because it wouldn't matter. 504 over 5. Always exact answers here. This one's going to be the more interesting one. And I think I need to take a moment to slow down on this guy in particular. Notice that my x squared will go to x cubed over 3. But because it's an odd power, then minus sign can come out. Therefore, 2 negatives make a positive. So what actually ends up happening here is I have a 1/3, and then I have x cubed, and I'm going to toss in that negative y and positive y. So I'm going to get a 2/3. And then this guy now is going to be a y cubed. And then 6y plus 3dy. Because again, that 2 came from the fact that there's 2 of them. Okay, so I plugged them both in, and then minus, 2 negatives make a positive like we had way up here. So instead of saying y plus y, I'm saying y cubed plus y cubed is 2y cubed. That's why I put a 2 in the front. But looking around, this looks, again, very similar to what we just did a second ago. And in fact, I'm looking right at it. This is a 12 and a 6. If I could make this into a 12 and a 6, I think we're going to be really happy. Yeah. Yeah, exactly. So in a way, without having to do extra math, I'm like doing this. I'm going right back to this guy. So the only difference between this and this is the divide by 3. So it's kind of funny. I'm saying it's my previous answer divided by 3. So obviously I just put a 15 in there and hope for the best. This is a good test question. No. And then finally, they want this one, the I naught business. Well, I looked at the formulas, and for the two-dimensional, I think you just add these two together. And so I know that's kind of funny, but you're just going to take this plus this, and that's going to be your answer. All right, Chad, common denominator. Come on. It's not that hard, is it? That's what I was told by the book. I mean, there's a formula for it. I just, why would I use a formula if I just could do the plus thing? Was it taking the path of least resistance? Hopefully. Now, again, I'm just dividing these guys. One last thing I just want to verify is that 44 over 118 is indeed that. Oh. That's not the right answer, is it? No. No. Oh, it's the other way. You have to flip it. My bad. It's the 118 over 44. Okay. Oh. It's still not right. Okay, are the other ones okay? Let me do that 15 one over there. So then I got this guy divide by 15. Okay, so these are all good. I still have this one wrong. And it's just slightly wrong, man. Okay, so yeah, let's look at my numerator. Because I'm pretty sure the 44 is fine because it's going to cancel with a 4. So this guy right here is wrong. So let's use a different color to say I'm wrong. Okay. And I'm just going to say, if everything else has been working out great, it must be a minor mistake. Because I've been copying that style every time, right? So it can't be that wrong. In a way, I have the 2y. So I have a 2y squared, and now I make it a cube, and I double that here. And so then I said 4th power divided by 4, 3, I'll get a 2. I'm just going to verify it yet again that I got 3y to the 4th, 2y cubed, and y is equal to 2. You know what? I was doing it by hand. That's my problem. Or by hand, by head. Yeah. Stupid Chad. There it is. Okay. So 2 to the 4th is 16 times 3 is not 96. I think I was thinking 32 times 3 is 96. Yeah, I was definitely wrong. Okay, I was wrong. This is why we have calculators. right? Are we cool with that? Okay, now it's fine. Yay. Well, that took 30 minutes. And I know, you go through the whole problem and you get everything right, and then at the very end, you can't add. You just can't add. Gosh. Man. Just, that's math for you. Any questions? Good, because I really don't want to do it again. No, I'm playing. Hi. You here for coffee? Okay, you can do that. Thanks. Oh, well, I understand. Aren't you in class right now? All right, that's cool, man. That's cool. So, this problem here, I was looking at it before class and I didn't want to do it. So, I think I want to come back and do that one next because it's so similar to what we just did, but it's even more. As in, like, I don't want to do it. So wouldn't it be the exact same problem, but except for you have like a integral and variable? True, but now if we go back up for the formulas for I sub x and I sub y in 3 dimensions, you see how they got a little bit more intense? Now you know why I didn't want to do it today. Because that alone would take a lot of time. That might be a whole class. Yeah. Yeah, we only have 30 minutes left. I don't want to do that one. So I want to do this one, and then I do need to leave early if I can because I got that meeting. Yeah. So yeah, let's do this one here. So we'll skip that. You're going to remind me to come back to it, right? Because it's like, hey Chad, you skipped the hard one. So let's graph our region just like we did last time. And I think it would be easier if I got z equals. I mean, that's normally what I think of, right? So if you do this, and if you do this, actually, yeah. No. Hold on. I want to do this. So here I got z is equal to 1 minus x. But when I move these guys over, I get z is equal to 1 plus x. Or rather, negative x plus 1, positive x plus 1. It's 45 degrees, but it's shifted up by 1, right? So in a way, my graph is from 1 going up at 45 or down at 45. And again, this is x and z, just in case you're wondering. Yes. Yes. This is a z, but you're right. I'm using x and z because, well, me too. So we have this, and then they have y equals 0, which is what you're looking at right there. That's like the picture of y equals 0. And then y equals this square root of z. I'm actually a little nervous. So, yeah. Let's try that. Yeah. So if I did it this way, so z equals y squared. Yes. No. Give me a second here. Yeah. Okay. I think I got it. Okay. If you look at this as the xy plane and then z, in a way here what you have are 2 lines that seem to like be coming off like this. Okay. And then we have this guy that kind of looks like that. And again, they're in different planes in a way. They're not supposed to look like that, but I think what I'm having here is this kind of zone in there. I think. So, and it's not, I can't do that very well. Like in 3D, I could try 3D. With the X and Z plane, I have them, let me use different colors. I have them coming out like this. And then it kind of like continues that way all the way down. Okay, so it's kind of like this big triangle kind of looking thingy. But for this, I have z equals y squared. It's like a parabola, like this, all the way down. Okay. So at some point, these parabolas are colliding with these planes, and it makes like this. Well, it makes a cheese wedge. There you go. Everything's a cheese wedge. I mean, every time, right? Are you advocating to cheat? No, it's using your resources, Chad. When have I heard that before? um. Yeah. You go to a bank. I'm gonna rob you, but I'm not asking for $1 million. I just want a couple thousand. So you can see what I was talking about, the two little plane thingies, and then I have this dude going on. Well, where they all intersect is blum 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 blum. This little zone in here. Oh, you can't see it. I'm sorry. Let's back up. There we go. That little like area. Oh, well, there you go. Let's just rotate it slowly. So I'm going to zoom out just a tiny bit more here. See how they're colliding at the bottom right there? It's the inside of this tent. Yeah, I think they're all at ones. Yeah, that looks like you're right. So that's my shape. Very strange shape. And then not just the shape, not just the volume, but it has a variable density. Yeah. Yep. It's like a weird cutout cheese wedge thingy. Yeah. Cheese wedge gone wrong. Now that's called Swiss. Oh. That's called baby Swiss. So it just says what's the mass, and thankfully that's it. In a way here, it's going to be triple integral of this stuff, and then dz dy dx, and like that's it. So that is all we need to find. Not too bad, right? Okay. It's scaring me. True. So let's set up our integral limits. And again, I'm trying to give myself a lot of room right now. And I'm going to guess the dz dy dx kind of thing. So as far as z's go, I have something. Now, going back to the picture for a second, it's still rotating. The green is going to be at the bottom, technically, isn't it? And then on the top are these two planes thing, right? But that's, if I'm thinking about it, oh man, and the variable density is not good, because then I would have just like cut it in half and did one of them. I think that I'm going to have to not do z first, unfortunately, because see how I have two different tops? I'd have the blue and the red. I have to do two different integrals. I don't want to do that. I mean, you can, but I don't want to. Maybe we should, just for simplicity's sake. Because see, here's my theory. I'm saying that this is my bottom, and these are my tops, right? And I would do one, and then I do the other. I can't just say cut it in half and call it a day, because I have a variable density. So they will get different answers in there. Would you want to go down that road? It's not that bad. I just have to do two integrals. Or would you want me to like think of this differently than what you see here somehow, and then come up with an answer? You can do. Hold on. I was trying to get it to work. Okay, here. Nope. Nah. Well, I'm trying to rotate it. Okay, here. Is this gonna work? That's not. No, Chad. No, that's not gonna work. Rotate. So dumb. Okay, so what my theory then is that I have a top and a bottom. Right. Yeah. This is my top. That's my bottom. And then I would say this part later. I would come in with the parabola later. Let's try that. So I'm going to do basically like a X first, is what I'm thinking. So let me try instead. I'm going to do an X first, and then I'm going to do a DZ, DY maybe, and these I might have to switch. But if I'm going to do X's, then I'm looking right here, and I want to make my top and my bottom, right? In terms of Z. Again, but going back to what that picture looked like, it was something like this. So this is the top, and this is the bottom. The negative's on the bottom one, right? So this would be my bottom, but I need it X equals to make it work, okay? So what I'm actually going to have to do to make this work, I'm going to have to do this. So then I got, this is X equals, this is X equals. I actually get 1 minus Z. And the same thing here, I'm actually moving the 1 over, so then I get X equals 1 plus Z, or Z plus Z minus 1. That's what I'm doing. Am I right with that? Z minus 1? And 1 minus Z? Yeah, it just looks funky, you know. I don't like it. If you don't mind, I'm gonna. I'm just going nuts right here. I would rather do a negative Z plus 1. So at least they're kind of lined up like a line, you know. I can maybe go from there. Oof. Because I now have Z's, if I do Z next, Z equals, then it'll have to be in terms of Y, which I actually have. Now, going back to the picture, and I need to make this, yeah, is this is right side up again? Okay, that works. So, looking at my Z's, this thing here is at the bottom. So, what would be at the top? Like, what's the top number for Z? 1. And I think just 1 might work. Maybe. So, I'm going to say this is a Z equals, and then we're going to do Y squared, and I'm going to do 1. Z equals 1. And then my Y values, you could probably just assume they're going to be 0 and 1, but let's just verify. Go back to the picture one more time. My Y values are actually, oh, look. See, these are right here. What's this and what's that? What do you think? Yeah, negative 1 to 1. Since we've already cheated, let's keep going. Exactly right. I don't want to spend 10 minutes doing this, and then it was wrong to begin with. And then you're looking through thinking, I know I did something wrong along the way, when really the integration limits were wrong. Like your setup was wrong. And that's just sad. You don't want to go through that. Nobody should be doing that. So let's check this out for ourselves. If we get the right answer, cool, we'll do the math. But we're just verifying here. Like I'm really suspicious of some of these. dx, dz, dy. At least it's somewhat coherent. Flash the answer. Not that one. We're close. Okay, we got the 15 at least. Technical details. So, haven't you seen my Cal 2 videos? Absolute value, just meh. Let me try something simple. I don't think that this is going to really affect it. See, so I'm gonna keep with what I got here for a moment. But go ahead. Let me go back.
Oh no. Okay, it's 89. So I was gonna say when you put a y up, it did 8 over 15.
Yeah. Okay. Did I miss something about the bottom? See, I'm wondering more about that 1. Yeah, because I'm saying, is there a way for this to be in terms of y? So I got my bottom and my top. See, these are my tops, man. See that? It's just too much. I'm going to do two integrals. I don't care. I'm going to do two integrals. So let me just try two integrals because that's what I'm looking at, and my brain just isn't functioning that way right now. So dz, dy, dx plus, and again, because we have Desmos, we can just like quickly just toss it in and see what happens. So top and bottom, I know for sure this is on my bottom, and these are my different tops. Okay, for each side. So then I'm gonna do y squared, and then one of them was negative x plus 1, and it doesn't matter which one because you're just adding them in the end. And here I'm going to go y squared, and it was just x plus 1. Okay, for my y's, I need y's in terms of x's, but I don't think I have that. So I'm going to go negative 1 to 1. And my x's, I think it's just 0 to 1. X. No, x is going to be negative 1 to 1 as well. Do you mind if I try this? I don't know if it'll work, but I want to try it. Sure. Now, are you losing hope in me? You should. That's why we come to class. Okay. Like, all right. That's not too bad. Nope. Come on now. You're good? Okay. Oh. Well, okay then. And oh, is that not the same thing? Dang. Okay, well, darn, man. Should I just go to the homework and see what they got? Ah. Okay, well, for one, it's a very complicated shape. Good test question? Okay, I'm gonna go to the assignment. What number is that again? 15.6. And it's one of the last ones because it's got to be really hard, right? Yeah. Let's look around. Oh, it is the last one. Perfect. So ask my instructor, how do I do this? Okay. So that's very similar to what we had. I think I did my drawing off to the side over here. So, but I'm still seeing, we did the 3D picture. It's top and bottom. No, man, I don't want to do this one. Just show, okay, view an example. Is that quicker? Okay. Just give me the limits, bro. Okay. So they did dy, dx, dz, but you can see we have this thing where the x equals. We were right on track with that. So all they did was switch things around so that the z comes last. I mean, we're really close. So let me, I want to look back at what we were doing. Give me a second here. What if I do that? And this? And there. So ignore the second attempt. That was dumb. We got time? Not much. Because I gotta get going. But I want to at least look at it and see what is wrong with mine. I mean, I'm really close. I'm really close to what they got. So yeah, see, I think that this is where I'm having a hang up. They're in a way going from 0 to this number here. So it's kind of like they're flipping them and then they're putting a 0 down there. I wonder if I did that instead. So let me pull up my Desmos here real quick. I just want to see, can I get it the same way? No, 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 no. Okay. The same way, but maybe like, so what if I went from 0 to y squared? Let's just try. I might have to switch my tactics here in a second, but I just want to try something. You can see we're really close, right? dx, dz, dy. Now, okay, we're close. Put a 1 down here. 0. Okay. Well, okay. We're pretty close. Do you see that what they did? They left it with the square root and put the y up front. So why is the y up front better than second? Why do I have to switch these? You know what I mean? I don't know. But now you know what's going on. Right, right. Oh, so I'm switching not those two, but something. I'm switching them all. Right. But in the end, you can see that we were definitely getting on the right track. And again, if I switch this, it would be the square root. So we're really, really close. I don't know why exactly. Maybe I'm just not seeing it right. That's fine. I don't mind looking stupid. Are we good? I'm done for the day. I got to go do other things now. So thanks for hanging out, guys, and seeing how dumb I am. Yay.